Hi everyone, welcome to this session. My name is Somajit Goswami. In this session, we will be looking at CAT Quantitative Abilities Rapid Concept Series. So this is a end-to-end algebra A to Z kind of a situation, which you can also refer to as a refresher course, which means 100% of the syllabus will be covered at one shot. There are a few pointers which I want you to pay attention to. Watch the video at 1.5x speed or even 2x speed, whichever is more apt for you. That will enhance your viewing experience. If you have any doubt, any query, anything that you would like to share with me, comment that down. Finally, relax. Okay, and let's start the session. So the first concept is algebraic identities. Okay, so typically algebra starts off by the identities. In this session, however, I'm not going to tell you a plus b whole square and all that. I will start off with the most important things which are important in identities. That is, first of all, everybody needs to know the factorization of a raised to the power n minus b raised to the power n when n can be even or odd. This is important. N can be anything, even or odd. In this case, two things you need to just remember. That is, this thing can be factorized as a minus b. So I am directly saying that a raised to the power n minus b raised to the power n is going to be completely divisible by a minus b. For that, n has to be even or odd, whatever. But the factorization of this thing is going to be a raised to the power n minus 1 plus a raised to the power n minus 2b plus a raised to the power n minus 3b square, so on till b raised to the power n minus 1. That's it. Okay, so this is an interesting concept that one needs to remember. This is important for your number system also. This is helpful in remainders. The second thing is the same for a raised to the power n minus b raised to the power n, but this time n is only, please pay attention, only even. Okay, n is only even. In this case, a raised to the power n minus b raised to the power n will be divisible by a plus b also. So the factorization will be something like this: a raised to the power n minus 1. This time the terms will be negative alternately, okay, which is going to be a raised to the power n minus 1 minus a raised to the power n minus 2 b plus dot dot dot, and finally b raised to the power n minus 1. Okay, if you want to perhaps take a screenshot, you can take screenshot also, but for our purposes, which is more important, is a raised to the power n minus b raised to the power n divisible by a plus b? Yes, if n is only even. A raised to the power n minus b raised to the power n is divisible by a minus b? Yes, if n is even or odd. So a minus b to divisible is a factor, whatever is the case. The last thing which you should be remembering is the a raised to the power n plus b raised to the power n. Okay, this is divisible by a plus b if n is odd. This is very important, if n is odd. And if you are, if you want to know the factorization, this is going to be similar to this one: a raised to the power n minus 1 minus a raised to the power n minus 2b plus dot dot dot, lastly b raised to the power n minus 1. That's it. Okay, now obviously the thing that I want you to take from this session is that a raised to the power n plus b raised to the power n will always be divisible by a plus b only when n is odd, and similarly for our purposes, this term, which is the other multiplication, this thing is not very important. But again, because we are learning identities, I'm giving you the factorized form as well. Okay, now a couple of simple identities if you want to recall. So let's say a plus b the whole cube. A plus b the whole cube can be very easily remembered as a cube plus 3a square b plus 3ab square plus b cube. Okay, similarly, if you have a negative sign over there, a minus b whole cube, so all the odd powers of b will be negative, so this one will become negative. This one is not an odd power, so this will stay positive, this will become negative. Now a cube plus b cube, that is equals to a plus b, this is important, a plus b into a square minus ab plus b square. Okay, and similarly a cube minus b cube, this is going to be a minus b multiplied by a square plus ab plus b square. Okay, these are some of the important things that you can remember. The others you already remember. One more thing which you can remember is a cube plus b cube plus c cube minus 3abc. So let me write that also here. A cube plus b cube plus c cube minus 3abc is a plus b plus c multiplied by a square plus b square plus c square minus ab minus bc minus ca. Typically, CAT has this idea that they will give you this a plus b plus c as 0. So if a plus b plus c is 0, then you can directly see, then I'm writing that thing also, a cube plus b cube plus c cube is equals to 3abc. This is something that has been asked as a standalone question in CAT also. Okay. Alright, so this is all for identities. Now let's go to the next topic, which is going to be important for us. So let's look at equations. So we'll start off by linear equations. The very first thing that I will ask you is that why they are called linear equations. Okay, and why not anything else? So an expression of the form, let's say 2x plus 3y is equal to 6. Why is it called a linear equation? For a simple line, if you jot them down in as a graph, you will always realize that this line is going to be a line, a straight line. Okay, obviously the slope is negative, so it is going to be a line like this, and because the graph is that of a line, so that's why these type of equations are called linear equations. Okay, also I would like to say that solving linear equations is always favorable simultaneously. If you have two equations, you can solve them simultaneously and you can get the answers to the solutions. Okay, now let's move to number of roots. Okay, for linear equations, number of roots. So let's say a general form. So I haven't defined the general form of a linear equation, so let me define it over there. This is ax plus by is equals to c. This is the general form of a linear equation. So suppose we have two equations of the type a1x plus b1y is equals to c1, and the other equation is a2x plus b2y is equals to c2. Now obviously I will not go into too much of details. I'll directly give you the coefficient of x, y and the constant terms will give you the number of solutions. Okay, to make things a little easier for you, I will take an example. So the example will tell you. So suppose I take 6x plus 9y, that is equals to 20. This is one equation, and the other equation as 9x plus 13.5y is equals to 30. If you pay attention at the coefficients, you will realize the coefficients of x, y and the constant term can be written down as, okay, so I am writing this down, a1 by a2, then you keep a bracket like this, b1 by b2, then a bracket c1 by c2. Now whatever whatever you get in these brackets will define whether or not you will get how many roots for the linear equation. If you get a equal to sign, you will get something. If you don't get a equal to sign, we'll get something else. Now let us look at the example. So if you pay attention, this is 6 by 9 is 2 by 3. Okay, and 9 by 13.5, if you just multiply 2, you will get 18, and this one will become 27. 18 by 27 again is 2 by 3. So in other words, for the first set I am getting a1 by a2 is equals to b1 by b2, and if you look at the other thing, which is 20 by 30, that is also c1 by c2, that is 2 by 3. So 2 by 3 here, 2 by 3 here, 2 by 3 here. So all of this a1 by a2, b1 by b2, c1 by c2, all the terms are equal. In other words, this is will have infinite solutions, and I'll tell you why you will have infinite solutions. Because these are not different line, they are the same line. They are effectively same line but different points. So if you suppose you plot this thing, instead of these 2 points, I'm now looking at these 2 points. Okay, I'm just looking at the multiple of x and y. So effectively they're the same line. Okay, now let's take another example to understand the other topic. So let me erase the slide so that I have some space. Now let's take an example. Instead of an example, let's say in the previous case I had a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Suppose in the next stage I say the last term is not equals, which is a1 by a2 is equals to b1 by b2, but it is not equals to c1 by c2. In that case, what you will have is, this is something called as a inconsistent equations. Inconsistent equation means you will find no solutions. Please remember, in the first case we found infinite solutions. Here we will find no solution for a simple reason, because the coefficient of these two lines, a1x, b1y and c1, they are effectively parallel lines. Okay, so I can represent them like this. So their slopes are actually going to be equal. Okay, now the last idea, which is what happens when all the coefficients are unequal. That is, perhaps I'm pretty sure you already know the answer to that, but what happens when all the coefficients are unequal? This is a consistent equations, and in this case, if you have two equations, a1x plus b1y plus c1 is equals to c1 and a2x plus b2y is equals to c2, in that case you will actually get something like this, and you will get a unique solution. Okay, so when the coefficients are all not equal, you get consistent equations, and in other words, you can also say there will be one unique solutions. Okay, that is very important. All right, now let's go to the